Tahniah. Siaran langsung ini dibawakan khas kepada anda oleh Akademi YouTuber Malaysia, sebuah inisiatif e-didik Malaysia dan Kelab Guru Malaysia. Tumpukan perhatian anda, siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Good evening, teachers, parents, and all the wonderful students. Welcome to Pusat Tuisyen Academy YouTuber. Bermula percuma, selamanya percuma. How are you doing today? I hope all of you are ready for today's lesson. Before we proceed, let's begin our session by reciting a prayer for Muslims. The non-Muslims may pray according to your own religions. Let me introduce myself. I'm teacher Lau from SMK Tinggi Klang, the moderator of the day. We at Pusat Tuisyen Academy YouTuber will provide you with free online classes. Let's take this opportunity to do your revisions. So are you ready? Let me introduce our teacher for today's lesson. We have Cikgu Shahnon from College Matrikulasi Pulau Pinang. We are now live on Cikgu Shahnon's channel. Please support his channel by clicking subscribe now. The topic of today's lesson is polar molecules. And today with us, we have teacher Kong from College Matrikulasi Perak, who is a control host in charge ensure the smoothness of our lesson on technical support. And we also have teacher Tang from College Matrikulasi Selangor as observer to ensure the smoothness of our lesson. So before we begin, I have a few reminders to all of you. First, please pay attention to our lesson. Stop chatting and use that chat session wisely. And regarding the certificate link, the link will be given at the end of our session. You can use MOE or Lerima account when you fill in your particulars, and make sure to listen to the passcode given by me during the lesson, and fill in the form within the time limit, which is 30 minutes. So first I will give you the three passcodes. There is A88, okay, I repeat, A88. So without further ado, let's welcome Cikgu Shahnon.
Assalamualaikum warahmatullahi. Let's watch this video first. Intro of our pre-U chemistry. All right. This is also our intro. All right. Aplikasi Akademi YouTuber, koleksi video pendidikan terbesar di Malaysia. I hope all of you can muat turun this application from get it on Google Play. Okay. All right. This is our lesson today, molecular polarity. Okay, before that, this is definition of dipole moment. Okay, the dipole moment or mu of a molecule is the product of the magnitude of the charge Q and the distance R that separate the center of positive and negative charge. Okay, the mu equal to Q. Q is quantity of charge and R is distance. The unit is dBA or cm charge, and m here may be meter. Okay, and a molecule is considered polar if that has a net dipole moment not equal to zero, mu not equal to zero. Okay, if a molecule is non-polar, the net dipole moment equal to zero. Okay? We will use this mu not equal to zero and mu equal to zero to consider a molecule as a polar or non-polar. Okay, bond dipole. The bond, covalent bond, okay, the covalent bond, we can say that the covalent bond is polar or non-polar. Depends on electronegativity differences. Okay, between two bonded atoms characterize the covalent bond as a polar or non-polar. And then to describe the molecule as a dipole, the molecule must have one or more polar covalent bond. Okay, at least one polar covalent bond. The dipole from each bond must combine to give a net charge separation not equal to zero. Okay, so in this case we have a molecule that the bond is polar, and then from that we see the molecule, whether the molecule is polar or non-polar. And we just go to the what we call exercise, okay, predicting the molecular polarity. A lot of from 1 to 25, okay, a lot of exercise. So today, this is what we will going to do. We just draw the Lewis structure and we want to predict whether the molecule is polar or not. Okay. The first one is hydrogen, chlorine, and oxygen. All right. So we will use this one. Okay. First, let me see the. Okay, I will use the red one. Okay. Hydrogen. If you look at hydrogen here, this is hydrogen. I think I should make it more thick. Okay. Okay. Look at hydrogen. This is hydrogen. H2. This is hydrogen. If we write the Lewis structure, this is Lewis structure of hydrogen. Very easy. Okay. And hydrogen, there is no difference in electronegativity. So we just draw like this, mu equal to 0. So molecule of hydrogen is non-polar. Okay, this one is very easy. The same thing goes to, let me see this one. Okay, chlorine. Okay, chlorine. This is chlorine. And Lewis structure of chlorine like this. It has three lone pair here, 3 lone pair. And because there is no difference in electronegativity between these two atoms of chlorine, so the mu also equal to 0, and this is non-polar molecule. Okay, this is non-polar molecule. Okay, what happens if we have oxygen? Oxygen is O2, and we know that oxygen has two double bond here. It has double bond. Okay, this is a molecule of oxygen, double bond. Don't worry about the double bond. Don't worry about the bond. We just look at the molecule, the atom of oxygen. There is no difference in electronegativity between oxygen atoms. So mu equal to 0, and oxygen atom also non-polar. Non-polar. All right. And then I also has nitrogen. Okay, don't worry about nitrogen. I think I want to change the color. Nitrogen. Okay, this is nitrogen. Wow. Okay, this is nitrogen. Nitrogen has uh, a triple bond between nitrogen atom because there is no difference in electronegativity. We just write the mu equal to 0 and molecule of nitrogen is non-polar. Okay, this is clear, I think. Okay, we go to the let me see. Okay, this one. Okay, hydrogen, chlorine, oxygen, nitrogen. Now HCl and HF. Okay, we have hydrogen, HCl, HF, and NO. Okay, we still do atom. Do atom. Okay, let's see this one first. All right. Okay. Where is my viewboard? Okay. One. Okay, HCl. Now is HCl. If you write the Lewis structure of HCl, this is HCl. This is Lewis structure of HCl. But in this case, um, hydrogen and chlorine has different in electronegativity, and we know that chlorine is more electronegative than hydrogen. So we have to write the design of arrow like this. Okay, like this, and the head of arrow pointed to more electronegative. In this case, it's pointed to chlorine atom. And then we will write like this: mu not equal to 0. Okay, because we have a net charge that pointed to chlorine. So mu not equal to 0. In this case, HCl is polar molecule. Okay, polar molecule. The same thing goes to HF. HF. Okay, we look at HF. This is a Lewis structure of HF. Okay, and we know that H and F is more electronegative than fluorine. So the mu not equal to 0, and this is polar molecule. Okay, this is the easy one lah. Only two atoms. We call it dua atom. And then this one is not this one. Wait, where is NO? Is it NO? NO, okay, NO. All right. Okay, yes. Okay, NO, we have a NO and BeH2, right? NO. Okay, first we have to write the Lewis structure, and to write the Lewis structure, okay, first we have to know the how many valence electron of nitrogen. Nitrogen has 5, oxygen is 6, total is 11, right? And this is odd electron molecule, and this is the Lewis structure of nitrogen like this. 11, so we'll have this one. Okay, 2, 4, 6, 8, 10. Okay, this is Lewis structure of NO. This is odd electron molecule. We have like this, but don't worry about the lone pair here. The most important thing is we know which one is more electronegative. And from periodic table, we know that oxygen is more electronegative because if we refer to I think this one. Let me show you the not this one. Oh, this one. All right, this one. Okay, if you refer to this periodic table, this is nitrogen and this is oxygen. Oxygen on our more on our right hand side. Okay, more. Okay, let me. Okay, is it? All right. Okay. Okay, this is oxygen. This is oxygen. This is nitrogen. And we know that when we cross a period, the electronegativity of element will increase, right? The electronegativity of element will increase. So oxygen is more electronegative than nitrogen. Okay, and then because of that, I have to. Oops, what happened? Okay, because of that, we will write the okay the arrow is pointed to oxygen like this. The arrow will pointed to oxygen and the mu not equal to 0 and this molecule is polar. Okay, polar. And if you look at this molecule, the bond is polar and the molecule also polar. If we refer to this okay, this one. Okay, for hydrogen, chlorine, and oxygen and nitrogen gas, the bond is non-polar and the molecule also non-polar. Now we have two categories of molecule here: non-polar bond, non-polar molecule. Okay, non-polar bond and non-polar molecule. And for the second category is polar bond, polar molecule. Okay, polar bond and polar molecule. This one is polar bond. That's why we have a arrow here. We have an arrow pointed to more electronegative atom. Okay, the bond is polar and molecule also polar. Okay, now we look at for BeH2 and XeF2. Okay, BeH2 and XeF2. Okay. Oh, not this one. This one. Wait, no, this one. BeH2. Okay. Be. Okay. Go to the next. Three. BeH2. Where is my pen? Okay, this is my pen. BeH2. Okay, like this. And first we have to draw the Lewis structure. Be. Beryllium has how many valence electron? Beryllium 2, right? 2. Hydrogen is 1. 1 times 2. So total is 4. So the Lewis structure is like this. This is the structure of beryllium, BeH2. All right. In this case, we have to predict the molecular geometry of BeH2. Okay, the molecular geometry of BeH2 here is linear. This is linear because we have 2 bonding pair, 0 lone pair. Okay, the electron domain is 2, so linear. In this case, for BeH2, okay, we refer to, I want to refer to the electronegativity of BeNH. Okay, we refer to this one. Okay, BeNH2. Be. Okay, hydrogen is 2.20. Beryllium is 1.1. 1.3, yeah, 1.3. That's mean, no, this is magnesium. Okay, beryllium. Beryllium is 1.7, 1.57. 1.57. That's mean the arrow pointed to hydrogen. Okay, because hydrogen more electronegative than beryllium, which is 2.20. Okay, so the arrow is like this. Okay, we have one arrow pointed to hydrogen, and here also we have one arrow pointed to hydrogen, from beryllium to hydrogen and from beryllium to hydrogen. All right. So the bond is polar. The bond is polar because there are different in electronegativity between beryllium and hydrogen. But what happened to the molecule? In this case, the net dipole moment cancel each other. Okay, so because of that, mu equal to 0, and the molecule is non-polar. Okay, for BeH2, the molecule is non-polar, even though the bond is polar. Okay, we have a different electronegativity between beryllium and hydrogen. Okay, but the dipole moment cancel each other, and net dipole moment equal to 0. Okay, because of that, BeH2 non-polar molecule. Okay, this is the third category. Okay, we have third category now. The first category is, as I said just now, the category number 1 is non-polar bond, non-polar molecule, right? Non-polar molecule. The second category is polar bond, polar molecule. Okay, this is the third category. Polar bond, non-polar molecule. Okay, of course we will have the fourth category. Okay, the fourth category, this one polar bond, non-polar bond. Okay, non-polar bond but polar molecule. Okay, this one very rare lah, number 4. The category number 4 very rare because the bond is non-polar but the molecule is polar. Usually we will see these 3 categories. Okay, non-polar bond, non-polar molecule, polar bond, polar molecule, polar bond, non-polar molecule, and this one very rare, non-polar bond, polar molecule. Okay. Okay, BEH2, and then after BEH2 is XEF2, all right, XEF2. Okay, XEF2, we have a XEF2. Okay, in this XEF2, Xe is xenon, we know it has 8 valence electron, and fluorine 7 times 2, 14. Total is 20. 20, 22. Okay, 22. Total of electron is 22. So the Lewis structure. Okay, first you have to know how to write the Lewis structure. Okay, okay, and then the terminal atom. Make sure that terminal atom has 4 electron, for 8 electron. Okay, now it's 8 already. Okay, 8. Okay, 8, and then 8 times 2. 8 times 2 is 16. 16, 20, and 22. Okay, this is the Lewis structure of XeF2, and then we have to predict the geometry molecule of XeF2 according to Vesper model, valence shell electron pair repulsion. Okay, And the molecular geometry XEF2, we have 2 bonding pair and 2 lone pair. So this is a V shape, right? This is V shape. So I will write here the shape of XEF2, and then I want to predict the polarity XE. This is F, this is F, and here we have lone pair of XEF2. Okay. 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 Okay, Xe and F is more electronegative. In predictable, the most electronegative element is fluorine. All right. So if you see fluorine, we know that the arrow must pointed to fluorine. Okay, like this. Pointed to fluorine, pointed to fluorine, like this. And then the net dipole moment is here, okay, like this. So the mu not equal to 0, and this is polar molecule. Okay, this is polar molecule. XeF2 is polar molecule. Okay, if you look at here, this is XeF2. It has 2 terminal atom, and same goes to BeH2, 2 terminal atom. But by draw the Lewis structure and we predict the molecular geometry, we can see the difference in polarity. Okay, Xe is polar molecule, but BeH2 is not polar or non-polar because of the shape. Okay, the shape of molecule. This is linear. Usually, the linear molecule can cancel each other, but it's come with um, we have to look whether this is symmetry or not. Okay, we can say that BeH2 is symmetry, right? Because the terminal are the same. Okay, XeF2 is not symmetry because the shape is V shape. Okay, the V shape or band is not symmetry. Okay, so this is polar molecule, but BeH2 is a non-polar molecule. Okay, we go to the next. Now what times? 28. Oh, 2 minutes. Okay, 2 minutes. Okay, 2 minutes. Let me see the next is okay. Carbon dioxide and ammonia. Okay, carbon dioxide, ammonia. After this, we will take a break. Okay, we will take a break. Carbon dioxide and ammonia. Okay. First, this is oh, sorry. Lewis structure of carbon dioxide. Okay, I think easy for you to just memorize the carbon dioxide. Very easy. Carbon dioxide, CO, double bond, double bond, O, double bond, O. This is carbon dioxide because we produce carbon dioxide every day. Okay, we produce carbon dioxide every day. Of course, we have to know the structure of carbon dioxide. Same thing goes to H2O. Okay, same thing. Okay, what happened? Okay, H2O. You have to know the H2O. This is H2O. I think everybody should, chemistry students should know the shape of H2O because we drink water every day. Okay, V shape, O, H, and also carbon dioxide. Okay, carbon dioxide, we produce carbon dioxide every day. Okay, inhale oxygen and we produce carbon dioxide every day. Okay, this is carbon dioxide, this is H2O. Okay, okay. So the shape of carbon dioxide is linear and oxygen is more electronegative. Okay, this is the dipole moment of carbon dioxide. So the mu will cancel each other. Okay, we cancel each other. Mu equal to 0. So carbon dioxide is non-polar molecule. And for H2O, H2O, H and O more electronegative than hydrogen. So the arrow is pointed to oxygen, like this. And the net dipole moment, this is net dipole moment, okay, upward there, and mu not equal to 0, and this is polar molecule. This is how we predict the polarity of molecule. But first thing what you have to do is you have to know, write the Lewis structure, and then predict the shape of molecule. Okay, I think it's already 30 minutes. Maybe
Okay,
we
let's
can
take a break now.
okay.
Tuisyen online percuma. Tuisyen online percuma. Layari www.academyyoutuber bagi mengikuti tuisyen online secara percuma. Prasekolah, sekolah rendah, sekolah menengah, semua ada di Akademi YouTuber. Rujuk jadual di laman sesawang www.academyyoutuber.com. Semoga masa terluang anak-anak anda diisi dengan sebaiknya. Tuisyen online percuma mestilah Akademi YouTuber.
Okay, Cikgu Shahnon, you can continue now.
Okay, welcome back. Okay, we have a lot of here, and then we all just has 30 minutes. So I think I want to pick PCL3. All right, I think, all right. Which one? Okay, this one, SF6 and SS4. Okay, this one, SF6 and SH4, right? SF6, HS4. Okay. SF4 and SF6. Okay. Now, first number of valence electron of sulfur is 6. Fluorine is 7. 7 times 4 is 28, and total is 34. Okay, 34, right? And then this is skeletal structure of SS4. Okay. After that, make sure terminal has 8 electron, like this. 8 electron. Okay, 8 times 4, 32. Now balance 2 electron. We put it on center atom. Okay, this is Lewis structure of SS4. All right. 4 bonding pair, 1 lone pair. Okay, and electron domain is 5. Okay, 5 we refer to trigonal pyramidal. Okay, trigonal pyramidal, but this one we has 1 valence, 1 lone pair. So the shape is seesaw, like this. F, F, F. Okay. Okay, here is the lone pair. Okay, something like this. Okay, now I want to predict the polarity. Okay, we know that fluorine is the most electronegative. Okay, for flat. the number of the value of electronegativity of fluorine according to Pauling is 4 flat. Okay, if you got 4 flat, this means you got F. No. If you got F, you got 4 flat. Okay, the arrow pointed to F. This. Okay, this and this one and this one. Okay, these 2 arrow will cancel each other, but this 2 arrow here cannot cancel because this is lone pair and this is bonding pair. So the mu is not equal to 0, And S as 4 is polar molecule. Okay, and mu not equal to 0, and this is polar molecule. What happened to the F6? Okay, as F6. Okay, this is tip. If we have one central atom and six terminal, that means this is octahedral, because we cannot have seven. The central atom cannot have seven terminal attached to central atom. The maximum of central atom is 6. Okay, so from here I already know that this is octahedral, so no need to write all these things. Say this is octahedral, like this. Okay, for octahedral, F is more electronegative than sulfur. Okay, if you look at here, this up and down will cancel each other, and here also will cancel each other, and here also will cancel each other. So mu is equal to 0. This is non-polar molecule. In other words, is if we have a 5 basic shape, when we predicting a molecule according to valence shell electron pair repulsion, right? We have a linear, we have trigonal planar, we have a tetrahedral, trigonal bipyramidal, and octahedral. If we have these five kind of shape, and the terminal, all of the terminal are the same, then it will cancel each other, and the molecule is non-polar. Okay, this is the tips how we want to predict the polarity of a molecule, right? Because when we have this, all the terminal are the same, it will become what we call symmetry molecule. Symmetry. When it's symmetry, that means the dipole moment can cancel each other. Okay, and we look at the rest of them. Okay, here. All right. This one. Okay. C. Which one? Okay. CH3Br. 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 Okay. CH3Br. Okay. Okay. This one. CH3. CH3Br. All right. In CH3Br, okay, I want to give you a tips. Okay, a lot of tips today. Yeah? This is organic compound. For organic compound, carbon must has 4 bond. Okay, 4 bond. If for neutral carbon, for neutral organic compound. So this one carbon, it will attach with 3H and 1 Br. Okay, this is Lewis structure of H3Br. Okay, very easy. Okay, C and attached to 3 hydrogen atoms and Br. Okay, this is Lewis structure, and then it has 4 bonding pair, 0 lone pair, and electron domain is 4. 4 is tetrahedral, right? Tetrahedral. Okay, we write the tetrahedral geometry molecule of CH3, something like this. Okay. All right. This is CH3Br. Now we want to draw the arrow. Okay, the arrow that indicate the polarity. For hydrogen and carbon, okay, we look at hydrogen and carbon. Which one is more electronegative? Okay. We refer to this one. Hydrogen is 2.20. Hydrogen is okay. Hydrogen 2.20, and carbon 2.55. 2.55. Carbon is slightly higher in electronegativity, 2.55 and 2 point, 2.2 and 2.5. Okay, only slight different in electronegativity. All right, but it's still pointed to carbon. Okay, something like this. Okay, it's pointed to something here, something here. Okay, but bromine and carbon, of course, pointed to bromine, and the mu is not equal to 0 lah. The mu not equal to 0. This is polar molecule. This is polar molecule, and we can see from this molecule. This is asymmetry, because the terminal, one of the terminal here, different from hydrogen. If we have methane, for example, CH4, okay, CH4, okay, this is mu equal to 0. Okay, this is non-polar molecule. If we try to differentiate between CH3Br and CH4, we can see that for CH4, it is symmetry, okay, symmetry. And for symmetry molecule, the dipole moment can cancel each other. Okay, they can cancel each other, and that's why mu equal to 0, and this is polar molecule. If I change all the H here with fluorine, for example, all I change with fluorine, CH4, CH4, CF4, okay, CF4, okay. If I change with fluorine, then it also will become non-polar molecule, even though the bond is polar. Okay, where is it? Okay, this one. Okay, this one. In this case, the arrow will point to fluorine. The fluorine. Okay, this one I change CH4 with CF4. Okay, because the molecule now is symmetry. The dipole moment will cancel each other, and mu equal to 0, and the molecule becomes non-polar. But if I change this one with bromine, for example, one of them I change with bromine, then it's become polar. Even two, I change this down with bromine. Okay, now I have two fluorine and two bromine. Okay, two fluorine and two bromine. This molecule also will be polar because the dipole moment cannot cancel each other. Okay, the most important thing is the 4 of terminal must be the same. Then it will become non-polar molecule. Right now is 44. Okay, we go to the next is which one? Okay, SO3 and ClF3, I think. Okay, ClF3. ClF3. Right. ClF3. Where is my? Okay, this one. ClF3. Yeah. Okay. ClF3. Okay. First, valence electron of chlorine 7. F also 7 times 3, 21. Total is 28. And Cl, we have F, 3F. And as I said, make sure that terminal is octet. 8 times 3 is 24. So in chlorine, we'll have 2 lone pair. So 3 bonding pair, 2 lone pair. This is 5. This is T shape lah. This is T shape. Okay, the shape is like this. T. Yeah? F, 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 and here. All right. Of course, the T shape is this is not symmetry, or we call it asymmetry. And for asymmetry molecule, the dipole moment cannot cancel each other, and the mu is not equal to 0, and this is polar molecule. Okay, this is polar molecule. All right, I think I have to go to the next slide of my presentation, or otherwise I cannot finish this in 1 hour. Okay, this one. This one is quite what we call. Let me make it like this. Okay. Okay. This one is quite rare, as I mentioned before, because in NCl3, actually the difference in electronegativity, not much different. We can say that there is no difference in electronegativity between nitrogen and chlorine. Same goes to phosphorus and hydrogen. So if we find this molecule, we cannot write this one. We cannot write this one. Huh? We cannot write the like this. No, because there is no difference in electronegativity between chlorine and nitrogen. Okay, I will show you. This one. Okay, I'll show you the wait. Okay. Oops. Okay. Where is my? Wait. I cannot open my. Supposedly I can open this, but I don't know why. Okay, this one. Okay, suppose I can, but I don't know why. I want to show the value of electronegativity between nitrogen and chlorine. Okay, in other words, we can say that no difference in electronegativity. Okay, nitrogen and chlorine, phosphorus and hydrogen. That's why if you look at this, no arrow here, but this one, this molecule is quite rare, because non-polar bond, but the molecule is polar, molecule. Why this molecule is polar? Because of lone pair. Okay, the lone pair here, actually it has a little bit dipole moment like this. We can see the arrow here pointed out from nitrogen. Okay, because of the lone pair here is we can say that it has a dipole moment. The same goes to the phosphorus pH3 here. No difference in bond between phosphorus and hydrogen, but because it has a one lone pair here, so this molecule is a little bit polar, even though the bond is non-polar. Okay, this is category number 5. If I because before this I already categorized, all right, the molecule in four categories. Okay, the fourth categories. Okay, I just want to write the fourth categories is ozone. Okay, this is a molecule of ozone. Okay, ozone like this. Okay, ozone also fall in these categories because there is no difference in electronegativity between oxygen. So we cannot write any arrow from here to here because this is oxygen, no difference in electronegativity. But because ozone here has one lone pair. We can write the dipole moment up from central atom here, up there. So the mu is not equal to 0. This is polar molecule. Okay, ozone is polar molecule. Okay, oxygen, ozone, NCl3 and PH3 fall in these categories, non-polar bond but polar molecule. All right. All right, and then I have to delete all this thing, because or otherwise it will. Okay, let me delete this first. Okay. All right. Okay, summary. All molecules with 5 basic shape and same terminal atom are non-polar molecule. Okay, this is what we can summarize from for this 1 hour lesson. Okay, what is 5 basic shape? Linear, trigonal planar, tetrahedral, trigonal bipyramidal, and octahedral. Okay, 5 basic shape, same terminal atom, but must be same terminal atom so that it will become symmetry molecule, and the dipole moment, the net dipole moment will cancel each other equal to 0, and the molecule is non-polar. Okay, for example, carbon dioxide, this is linear. PCl5 is trigonal bipyramidal. CH4 is tetrahedral. SO3 trigonal planar. Yeah. AlCl3 also trigonal planar. Okay. Molecule with different terminal atom are non-polar molecule. Okay. Even though we have a 5 basic shape, we have tetrahedral, for example, but one of the terminal different from another. So this molecule, polar molecule. For example, CH3Cl. This is tetrahedral, but one of the terminal not the same. POCl3. Okay. The third one is all molecule with lone pair are polar. As we can see, trigonal pyramidal. Okay. Ozone, O3, trigonal pyramidal, right? It has one lone pair. All are polar except for linear in sp3d, except for linear in sp3d and square planar in sp3d2. Okay, because for square planar, actually the square planar, it has two lone pair, but the molecule actually is symmetry, it can cancel each other. The same goes to the linear that's come from trigonal bipyramidal. And the last one, no, this is example. For example, H2O. H2O is a V shape. It has two lone pair. PCl3 has one lone pair. PCl3 is a trigonal pyramidal, and ozone. Ozone is a V shape. Okay. I think that's all for today. I hope you enjoy this lesson and go back to our moderator.
Thank you, Cikgu Shahnon. Okay, so I last two passcodes. So last two passcodes are 7 and 8. 7 and 8. Okay, with God's grace, we are done with today's session. We have learned a lot from Cikgu Shahnon about polarity of molecules. Congratulations to those who are able to follow our session from the beginning till the end. And thank you very much, Cikgu Shahnon, for such an interesting lesson. So before I provide the certificate link, please off the live chat button and click subscribe button if you haven't. This is to show your appreciation to Cikgu Shahnon for giving you a free lesson today. Don't forget to click the bell button too, so you won't miss out any new videos and live classes from Cikgu Shahnon. If you like today's class, then please click like and share it to your social media friends. Let's share the knowledge you received today with them. Sharing is caring, right? Once again, I would like to thank you, Cikgu Shahnon, for the lesson. Thank you also to Teacher Kong and Teacher Tang for being with us today. I think that's all for now. See you in another session. Goodbye, everyone. Have a nice weekend.
Wow, banyaknya hadiah menarik menanti anda. Wah, kini Akademi YouTuber mengambil inisiatif baru di mana memberikan hadiah-hadiah ini secara percuma. Ya, percuma kepada anda semua. Bagaimana caranya? Dengan mengikuti kelas tuition online percuma Akademi YouTuber sambil mengutip mata kredit, anda dapat menukarkannya dengan hadiah-hadiah yang menarik ini. Tunggu apa lagi? Segalanya percuma. Jangan lepaskan peluang tau. Dah dapat banyak hadiah menarik, takkan nak lepaskan peluang. Layari www.academyyoutuber.com sekarang untuk maklumat lanjut.
Dibawakan kepada anda oleh Akademi YouTuber.